Before diving deep into the world of energy, it's important to clarify a concept that often causes confusion: the difference between power and energy. These two terms are sometimes used interchangeably in everyday language, but from a technical standpoint, and especially for financial modeling purposes, they mean very different things. Let's define these terms more precisely. Power is the rate at which electricity is generated or consumed. It tells us how fast energy is flowing, and it is measured in kilowatts, megawatts, or gigawatts. Energy, on the other hand, is the total amount of electricity used or produced over time, and it's measured in kilowatt hours, megawatt hours, or gigawatt hours. The units all scale by a factor of 1,000, and these tables give you a quick reference point for the most common units and how they convert. Let's look at how much electricity a typical household uses around the world. In the United States, the average household uses about 10,500 kilowatt hours per year. In Germany, it's around 3,500 to 4,000 kilowatt hours annually, while in France it's slightly higher at around 4,500 to 5,000 kilowatt hours. Households in Australia and Singapore fall somewhere in between, while a typical household in South Africa uses about 5,000 kilowatt hours each year. Let's put this into perspective. A medium-sized wind farm with a capacity of 25 megawatts operating at a 30% capacity factor will produce about 65,700 megawatt hours of electricity per year. That's enough to supply roughly 6,250 typical US households with electricity for an entire year. Now, let's look inside the household itself. Some appliances use relatively small amounts of electricity, like a vacuum cleaner or toaster, both averaging around 70 kilowatt hours per year. Others use much more. A dishwasher typically consumes about 300 kilowatt hours annually. A clothes dryer can use as much as 700 kilowatt hours per year. And a central air conditioning system is one of the biggest users, drawing about 2,000 kilowatt hours per year. Altogether, the choice and usage of appliances have a major impact on a household's total electricity consumption. Let's bring it all together with a simple analogy. Power is like your car's speed, how fast you're traveling at any given moment, say 60 miles per hour. Energy is like the distance you travel, for example, 60 miles if you drive at that speed for 1 hour. So if you increase your speed, you will cover more distance in less time. Just like increasing power leads to more energy output over a given time period. This relationship, rate versus total, is exactly the same when we talk about kilowatts and kilowatt hours. Let's quickly summarize what we've learned. Power measures the rate, how fast electricity is being produced or consumed, in units like kilowatts or megawatts. Energy measures the total quantity used or produced over time, in kilowatt hours or megawatt hours. If you multiply power by time, you get energy. The car analogy still holds. Power is your speed, energy is the distance you travel. And remember the unit conversions. 1 megawatt hour equals 1000 kilowatt hours, and 1 gigawatt equals 1000 megawatts or 1 million kilowatts. Getting these basics right is essential for everything we will cover next.